In which intervals is f of x concave up? Given that f of x is x to the fourth minus 4x cubed plus 12. Okay. We can do this. So the idea with concavity is it's kind of like the derivative of the derivative. So you could say it is the second derivative. And so with concavity, you can tell if a graph is concave up or concave down by if the portion can hold water. So if you think of like a cup would be concave up because you pour water into it, it holds water. If you have like a upside down cup U-shape like this, that'd be concave down because you pour water on it, slides off the edge. Not a technical definition. So a more technical definition would be along the lines of if you, for positive concavity, if the second derivative is positive. So take the first derivative, not too bad because these are the power rules, 4x squared. Then we'll take the second derivative, which is still not too bad because we're still dealing with power rules. And we'll set that equal to 0 because we want to find critical points of concavity, which are referred to as inflection points. You might encounter those when you're doing chemistry and you're looking for like the doing titrations. Okay, so now we'll solve this. 12x squared minus 24x equals 0. So x equals 0 is a possibility. And then we have 12x equals 24, x equals 24 over 2, 12, which equals 2. So x equals 0, x equals 2 are critical points. And so now what I'm going to do is I'm just going to draw this out as a table. Oh, I already used green. Dark purple? Is that a different purple? Okay, I'm good with that. So we have the points 0 and 2. And since we kind of have the entire world to deal with here, negative infinity to positive infinity, I'm going to leave some space on the end for both infinities. If desired, we'll see. Okay. And so now we want to test. So we know that these points both give 0 when we plug them into the second derivative, because we just found that. So now we want to find out if it's concave up or concave down between these areas. So we've got 3 points we'd like to test. So, orange. We'll start with, let's say -1. So we'll do -1, 1, and 3. Maybe 4. We'll go with 3. Okay. And I chose nice, easy numbers that would probably be easy to calculate. So 12 times -1 squared minus 24 times -1 equals 12 minus plus 24, which is 36, which is greater than 0. Okay, so this part is concave up. And the way I like to do that is I draw like a U. So when I want to do positive slope, I usually draw something like this. And then for positive f of x, I just do like a plus sign. For concavity, I like to draw a little U because a U is concave up, and it's kind of like, oh, good little visual sort of thing. Another thing you can use this kind of table for is for actually, if you have to graph it by hand, you probably won't be asked anything like this because you just don't have time for such. But if you had, deserted island, coconuts, mud, sticks, and you had to graph something by hand, that would be one way to do it. Get a good example. So this would be concave down, and then f double prime of 3 equals 12 times 3 squared minus 24 times 3, which equals 12 times 9 minus 24 times 3, which equals 12 times 9 minus 12 times 2 times 3. I just broke up 24 into 12 times 2. 12 times 9 minus 12 times 6, which equals 12 times 3. Because the 9 and the 12s minus 6 to the 12s gives you this, which is greater than 0. So concave up. And so here we're like, all right, we have a positive concavity from to the left side of 0, and we have a positive concavity on the right side of 2, which is this one right there. So in which intervals is f of x concave up? Yes, 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 yes. Bam. Excellent. Okay. So to look back and see what we did, we were told that we needed to do concavity. We immediately think second derivative. So we find the second derivative, set that equal to 0. That gives us some critical points. Those are the points of change of concavity, inflection points, if you will. We then test points. I'm going to say random points, but they weren't random. They were chosen specifically so that we could calculate them easily. -1 and 1, pretty good, solid choices. And then 3, well, that was a little bit more challenging than I like in life, but it wasn't too bad. We managed. We then looked at where it was concave up, and that was our answer. So not too bad. Again, when I do these tables, the symbols I usually like to use are plus, minus, arrow up, arrow down. It just kind of helps visualize what's going on. But we didn't actually find those, so I probably shouldn't draw them in. It's okay. All right, thank you much, and I'll see you guys for the next problem.